Ladies and gentlemen, put your hands together for Iliana, please.
Hi, everyone. I'm here to talk to you about Rails upgrades. My name is Iliana. I'm a senior engineer at Fin. I'm part of Team Datastores, and I always like to say Datastores is a bit of a funny team. We have quite a wide remit that we own, but some of the things that we own are databases, Elasticsearch, DynamoDB, but also the health of our core Rails platform. And I promise this is not a useless fact. It will make sense later. So yeah, this really is a story of 3 lines. The first line is the Rails versions over time. The second line is the Rails versions that Intercom was actually running. And it's the gap between these two that I want to take a look at. It's all the times that a Rails upgrade has crashed production and all the hundreds and thousands of tests that we had to fix along the way. And the third line tells the story of the 226 unique monkey patches that we've had to write since 2011. But first, let me tell you what Fin is. We are building an AI customer support agent and the customer service system behind it. You might have heard of us as Intercom, but we recently rebranded. Andy promised to hold me accountable if I say Intercom throughout this presentation, but some of the slides do say Intercom on them, from like old screenshots and stuff. Just so you know, Fin, Intercom, same thing. From the title of this talk, you can already tell we're a 15-year-old Rails monolith. And we have a couple of smaller apps responsible for things like billing and integrations, but our core application functionality is in that monolith. When I was submitting the talk, we had 3 million lines of code, but when I last checked about 2 weeks ago, we were approaching 4.5 million, so a bit bigger now. And we have 264 unique contributors to the code base, and that number is only growing as we hire more people. But this talk is about upgrades. And a couple of weeks back, just after we'd upgraded Ruby, I got this message from my colleague Daniel. And yes, the question is about Ruby, but the fundamental ask behind it was, why do we upgrade our dependencies? Honestly, Daniel kind of answered his own question a little bit. Security is one of the reasons to upgrade Rails, to upgrade any dependency. And in fact, for a while, it was one of the only reasons that we had. So let's take a look at the first few years of Fin. We started in 2011, and we were running the latest stable Rails version at the time, 3.0, which was a good start. We weren't like immediately behind or anything. And in the early days, the upgrades were just kind of background tasks. The code base was about 20,000 lines of code. There were only a handful of engineers working on it, and we didn't really need like a strategy or a grand plan or to convince anyone that we should do an upgrade. Our motivation was simply that security upgrades are great, and so is staying current. We were even comfortable enough to jump straight from Rails 3.0 to 3.2, and it worked great. Around this time, we also had to write our very first monkey patch. It's nothing too exciting. It just made it possible to render the same template on the same page multiple times without the IDs colliding. The code doesn't really matter. It was just, this was our first monkey patch. But it was the first of many. Let's jump forward a bit. We're not really a tiny startup anymore. We have more customers, a bigger app, and more engineers. And you can see that this is kind of where we start falling behind. We would keep up with security patches, but anything that didn't have a clear why would just get deprioritized. And this was not only valid for Rails upgrades. When you're small and moving fast, when the version that you're running is not end of life, the upgrade is the easy thing to drop off. Rails 4.0 came out in June 2013, and it took us 256 days to upgrade. At this point, you might be wondering, well, 3.2 is not end of life. You don't really have any issues. Why did you even bother to upgrade? Well, Rails 4.0 happened to add schema caching. This was a feature that we wanted to use to avoid rereading the whole database schema every time that the app booted. And it gave us a new reason to upgrade. We don't want to just stay on top of it anymore. We actually want to make use of new features of the framework. So we started using schema caching in production, but it didn't play so well with multi-threading. So this is where we felt the first real need to add monkey patches. So We wrote a monkey patch to fix whatever issues we were seeing. We deployed it to production to make sure that it worked. Later on, we upstreamed that monkey patch to Rails, and then removed it from our codebase. This is the perfect case for monkey patching, but you'll see later on that it doesn't always go like this. So, we upgrade to Rails 4.1 only a month after it's released. That's it. That was my talk. Job is done. We've learned our lesson. Upgrading early is good, and we will never fall behind on versions again. Or that's what we thought. So, a quick reminder of where we were on the timeline. So, Rails 2 has just been released, and we're on Rails 4.1, so of course we're just going to start working on the upgrade, right? Well, upgrading to Rails 4.2 took us almost a year and a half, and this is why. Well, there really was no dedicated owner to Rails upgrades. The app was much bigger now, and so was Finn. By 2015, we had over 120 engineers contributing to the code base, and the code base was about 500,000 lines of code. That's over 10 times the growth for both Finn and the monolith size. It was becoming unfeasible for someone to just jump in, upgrade Rails in an afternoon, a day, or even a week. Finn is also a very product-focused company. We try to run our infra teams relatively lean so product engineers can ship fast and safe. So things like app uptime and supporting product engineers just took priority. So nobody ended up owning dependency upgrades. We were also used to merging upgrades straight to master without much thought when we were still small and didn't have as many customers. And this started causing some trouble. This is the actual first attempt to upgrade to Rails 4.2. You can see the opening comment says, "Abandon all hope, you who enter here." It's because we already knew. We knew that Rails upgrades are not always as easy. They sometimes cause trouble. And what followed was this. So we would revert and upgrade and revert and upgrade and revert. And is there more? Yeah, upgrade again, revert again. OK, finally, after 5 attempts, we've upgraded. But we had over 10,000 paying customers at this point. We couldn't afford to cause new outages every time that we released an upgrade. And that actually made the problem even worse. We would be delaying the upgrades, we would be scared to cause an outage, and we would just wait. I'm also sure I don't have to tell you that Rails continued and continues to introduce new features, new bug fixes, some of which we needed back into our app. But because an upgrade was so overwhelming, instead of taking it on, we would just monkey patch that functionality back into our app. This is just one example of a Rails monkey patch that let us grab a fix from the Rails version, and we had to pay the cost of maintaining that monkey patch later on. Around this time, Finn faced one of our first major scaling challenges. As a customer support platform, one of our key models is conversations. And by 2018, this was our largest table. It had 25 billion rows. Half of those rows were added in the last year alone. Latency was continuously increasing. The table itself was difficult to manage. It was almost impossible to migrate. And we were already making use of things like caching, read replicas, and we were already running on the largest Aurora instance. So we had to shard horizontally. In Finn's case, the shard key is pretty obvious. We partitioned the data by app ID, which is our internal representation of customer ID, and we had 4 physical shards where the customer data was split between. But here is the problem. With 4 shards, a single conversation active record model had to talk to 4 different databases and pick the right one per query based on that app ID. Rails 4.2 assumed one model, one connection. So we built the connection detection and switching ourselves by monkey patching Rails. These are just some of the monkey patches that we had to add to make this work. And it was a lot of work. It was risky, it was fiddly, it involved lots of digging into Rails internals. This was the first bigger jump in the number of monkey patches that we had to support. And as you can see, it wasn't the only one. So we built out the ability for a single model to resolve to multiple connection pools by hand. And at this point, if you're a bit familiar with past Rails features, maybe you're thinking, wait, that was kind of a feature in Rails 5. And you would be right. This is the actual pull request in Rails, which allowed the same model to use more than one connection. This is exactly what we had built. But where were we on our timeline again? Rails 5 is out, and we'd been stuck on 4.2 and not upgraded for a while. We now have one more reason as to why we should upgrade. We are a big app running Rails in production. We can help shape features in Rails in a way they would be useful both to us, but also to the wider Rails community. So, all the monkey patching, all the workarounds, all the things that we had to do extra instead of just upgrading, it got to be too much. So, we decided to do it properly. So, what were we struggling with again? There was no dedicated owner to the upgrade. Well, great, let's just get a couple of people who would be responsible every time, and they would just do it. Big bang merges were taking production down. Well, we can try dual booting. We can run both Rails versions at the same time and gradually direct traffic to the new version. If there's something wrong, we can just roll back, and it's not going to cause a full outage. The monkey patch problem, that's a bit more difficult to fix. We just needed to upgrade earlier and make use of bug fixes and features as they were coming out. It took us 2 years to upgrade to 5.0. The issue was first opened in 2016, only a couple of months after Rails 5 was released. We finished it in 2018. And at this point, we're 2 versions behind. Rails 5.1 and 5.2 were already out, and 6 was just around the corner. We felt the pain of taking ages to do an upgrade and having to borrow improvements from future versions. So we've come up with some solutions. Let's do this properly. First, we'll create a mission statement outlining what we want to do. Then we create a tech plan saying how we want to achieve it. Then we share those 2 with the org. And at this point, we start getting some questions. Why the hell are you doing this now? What problem are you solving? But by now, our reasons have matured a bit more. We upgrade for security. We upgrade so we can give feedback on new features, shape Rails. We're a large monolith running Rails in production. We definitely have some opinions and face a variety of challenges that we can use to make the framework better. We've also added a new reason now. We've had numerous examples of having to backport behavior because we were so behind. And the health of our code base has significant effect on how fast we can move. Instead of spending time figuring out how to backport a fix or a feature, we can focus on building a good product for our customers. And the more behind we are, the more overwhelming it gets to upgrade. So great, we've convinced everyone. What's the next step? We set up the team to do the upgrade. We clean up leftover tasks from previous upgrades, so things like some monkey patches maybe were now outdated, or cleaning up deprecations, just small tasks. Then we set up dual booting so we can run both versions in production. We get a branch going, we run CI, we get the failing tests, we work with teams to fix them, we run dual CI, so no more tests that fail will be added. We work with teams to make sure that their issues work in the new version. If teams can't dedicate time, then we put it on their roadmap, and then we start gradual release. Wow, having a process is amazing, right? In July 2019, we're finally on the latest Rails version for about a month. So, Rails 6 shipped in August, so here we go again, right? But there's so many steps. We have to work with every team to fix their tests, to fix their issues. We have to make sure their features don't break. It's so much work, and we just did it. So we have to do it again, right? Well, here's the catch. Having some kind of structure around upgrades is great, but too much process creates its own kind of friction, especially if you rely on product teams who are busy building features for customers. They can't always make time for us, and we can't rely on them having time for us, no matter how good our reasons for upgrading are. So, let's take a look at the next era of upgrades at Fin. We took a much more balanced approach. So, we would assign an owner for the upgrade. They would be responsible for shipping and monitoring the upgrade in production and would follow a few simple steps. They would bump the Rails gem, make sure the app boots locally. They would get a branch build green. They would pull as many fixes as they can into separate pull requests so that the main pull request is kept as lean as possible. They would test the upgrade on a few high-traffic boxes first. This last step had replaced the dual booting strategy we had, and it allowed us to temporarily deploy the upgrade to a couple of boxes just to gain confidence that everything is fine. And that's it. Of course, sometimes we'd have to work with teams. Some upgrades were quicker than others, but they were mostly boring. We'd open a GitHub issue and work on it, open another GitHub issue and work on it. We'd trim down the process to something that was much more manageable, with clear steps and clear owners in case anything goes bad in production. To the point where monkey patches quietly became the most annoying part of an upgrade. We're sitting at around 60 monkey patches now. Each of them represented tech debt that we committed to when we added them. They have to be maintained, they break in surprising ways, they're not always well tested, and we weren't really using them as temporary fixes. We often knew that adding a monkey patch meant that it's just going to be there forever. We're never going to upstream it. As the number of monkey patches was growing, so were the changes required to support them in each new Rails upgrade. Just because we very often patched behavior that was changing frequently. But that still didn't stop us. In late 2023, just before Rails 7.1 was released, my team took on a huge project. We wanted to move all of our data off of AWS Aurora and onto PlanetScale, which runs on Vitesse. There's a public blog post about it if you're curious. But to give you a high-level idea of the project, we had to move 17 databases, amounting to 330 terabytes of data across. Earlier, I spoke about sharding the conversations table. Well, this table was the beginning of what we call our sharded database. Back then, conversations table was the only table in that database, and it was about 20 terabytes. But fast forward to 2024, the database held 80 tables and was 270 terabytes of data. The database setup itself was a bit more complicated, and of course, we wanted to keep it sharded as we were moving to PlanetScale. So we had to replace our in-house sharding with how sharding worked in Vitesse. So a quick overview, Vitesse shards by shard key, and the rule is very simple. Every query has to include that key in the where clause, so it can be routed to the correct shard. If the key is left out, Vitesse can't pick a shard, so the query gets scattered. This means that the queries can be slow, expensive, and prone to failure. Again, a reminder, in Intercom Finn's case, app_id is the obvious sharding key, so we needed each where clause to include the app_id and ID constraint. Does that sound familiar? If it does, it's because it's happening again. Rails 7.1 shipped query constraints, which is exactly what we needed. We can define query constraints on a given model. For example, the conversations model here has query constraints on app_id and ID, and those fields will automatically be added to our queries. Let's look at where we are on the timeline again. Something looks a bit different this time. We're on the latest Rails version, and 7.1 is right around the corner. So instead of building this functionality ourselves, we can run the 7.1 alpha release and get the branch ready to ship. The upgrade itself is pretty standard. I casually mentioned in the description there that we're going to stop logging some quite noisy deprecations and fix them in a follow-up. So we do that. But a couple of deprecations are a bit trickier. There's this secrets deprecation and then the cache format version deprecation, which we're a bit behind on. But we've got plenty of time before the next Rails release. So we silence them and park them for later. We just want to start using query constraints in production. And as we do, we start seeing some gaps. Adding in query constraints taught the model to carry the defined query constraints models. So if we do any queries to conversations, that would add app_id and ID the queries. But any associations still assumed the primary key as a single key. So conversations.messages builds the where conversation ID with no app_id, and the query gets scattered. So every association path that built a query had to be patched to carry the shard key. In a 4.5 million line monolith, there's tons of models, tons of association types, and tons of edge cases. So we wrote a lot of monkey patches to get this behavior. But here's what's different this time. For 13 years, patches meant Rails fixed this in a version that we can't reach yet. We're so behind. But finally, we're at the stage where Rails shipped the feature just recently. We can use it, we can provide feedback, and actually shape it. This is the other big jump in monkey patch count. At this point, we've reached 80 monkey patches running in production. That was not all query constraint monkey patches, of course, but when we were in the mindset of having to deliver a big data migration, the easy way out of a bug was to monkey patch. And we told ourselves, of course, once PlanetScale migration is done, we'll go over and upstream everything. Yeah. But anyway, we adapt query constraints to our setup and start moving data. 330 terabytes of it. Very much all hands on deck. And you can see where this is going now. We fall behind again. Not because we didn't care this time. We'd learned this lesson. But, as I said, Team Datastores is responsible for both our databases and our core Rails platform. And when there's a massive database project at hand, everyone who would normally do Rails upgrades was on it too. And Rails upgrades still need attention, even the quick ones. So 7.2 ships without us, 8.0 ships without us. We would open an issue and start chipping away at the blockers alongside the PlanetScale move. Remember those 2 deprecations that we parked? They weren't really side project material. The secret one was easy because we knew that the alternative provided by Rails was something that we couldn't use, so we had to either monkey patch it or create a gem to maintain. But the story was slightly different with the cache format one. And because it was quite difficult to focus on it solely, the issue was open for so long and our automation was like, "Hi, are you still doing this? Hello?" So we group up and we're like, okay, let's resolve the deprecation so that the 7.2 upgrade is eventually easy when we get the time. So we ship the format change and quickly cause an incident. Our databases are suddenly under huge pressure. We see customer-facing latencies and errors. This is the graph of the queries that run on the database, and that massive spike happened right after we released the new cache version. So clearly something's wrong with the cache, right? Some tables show over 100 times the number of queries that they usually do. So we do some digging, and we find out that the new cache format made the items smaller. This is usually a good thing, but we had a theory that memcached version we were running was evicting smaller items more often. So the fix here is, let's try upgrade memcached and see if the bug is fixed, right? Well, it was quite impossible at the time to take on upgrading all of our cache clusters when we weren't even sure that that was the problem. It was just a theory, and we were also moving all of that data to PlanetScale. So, can you guess what we did? We monkey patched. The old format had 80 bytes of overhead, and the new one had 3. So we literally padded the payload with a 77-character string to make them similar size again, of course. We enabled the new cache format for a subset of our customers. It worked. And then we enabled it for everyone. It was great. But that monkey patch did cause us some trouble later. And this is the whole point, right? A monkey patch doesn't fix the problem. It just defers finding the real solution. It's a trade-off that you're choosing to make. And in the middle of a 330 terabyte database provider migration, it seemed like a reasonable one. With the big blockers cleared, we finally do 7.2. And shortly after, we do Rails 8. While the upgrades themselves are not zero risk, they're not that easy, and they still take time and care, at this point, we'd set up a good process around them, and we're able to gain confidence and avoid big customer-facing outages every time. But we still have over 100 monkey patches at this point. And again, they become the most annoying part about the upgrade. You can see here some of the monkey patches that we've had to update, all because there was some change in Rails. We also had patches for non-customer-facing behavior, which tend to be less thoroughly tested and therefore not caught in CI. For example, here we had monkey patch tally to throw an exception if we try to cache a whole active record model, including its entire internal structure and private constants. The patch had stopped working at some point, and active record models ended up in the cache. And this was only surfaced when the internal structure has changed after a Rails upgrade. So you can see how painful it was dealing with all the tech debt we'd accumulated. But hey, at least we're back on track and into the last era of Fin. By the time 8.1 lands, we've finished moving our biggest and busiest tables onto PlanetScale, so we have some breathing room to do the upgrade properly. The Rails 8.1 upgrade is relatively straightforward. And then, just a week later, we move Fin onto Rails Edge. So, what does running Edge actually look like? We have a small team of 5 people, and if this sounds scary, we don't all work on Rails full-time, but we have someone assigned as an owner of the upgrade. And we do an upgrade every week. And because the diff each week is quite tiny, we can read every changed file if we need to, and immediately spot if behavior has changed. These are just some of the examples of things that we were able to fix as we see them happening. This is not to say, of course, that we never have incidents. Of course we do. Just last week, I was in charge to do the weekly upgrade, and after I shipped it, there was a big spike of exceptions that I had to revert. But once I saw that, it was much easier to then pinpoint what happened. I could see the whole diff in the changes that I shipped, and I could investigate whether it was a regression in Rails, if it was something weird that our app was doing, or something in between. And how do we think about monkey patches now that we're running Rails Edge? Well, they didn't disappear overnight. They still need to be maintained as we do our weekly upgrades, but behavior changes are much easier to spot. We can also remove monkey patches, both if they were upstreamed by us, but also upstreamed by others, so we can stop relying on behavior early on. Again, just some examples of monkey patches that we were able to upstream. This one, for example, was actually upstreamed by someone else. But because, again, we could see the diff of the Rails change very easy, we knew we could just remove it. And if we'd left it in until the next stable release was out, I can't imagine going through the whole Rails diff at that point. And maybe we wouldn't have even noticed that this behavior was upstreamed. And that monkey patch could have stayed in our app for years, while the Rails behavior behind it was changing. Running Rails Edge also doesn't mean we never add monkey patches again. It just means that the ones we do add are mostly temporary fixes for gems that just haven't caught up to Edge yet. And we get to upstream those too. And for the first time in a long time, during a Rails upgrade, instead of the monkey patch going up, it was actually going down. So, what did 15 years teach us? Small continuous upgrades are much easier to prioritize and execute and beat a massive release every time. Most weeks, the changes shipped in Rails are only a couple of files, and the blast radius is much, much smaller. Running Edge means we can spot a bug, fix it in Rails, or adapt our app, and we can have it in production same day. We also learned that monkey patches can be a great tool. We use them to verify correctness before upstreaming things to Rails. We use them to test a hypothesis or detect potential failure cases. But they're also tech debt. You accept it every time you add them, and can be a trap when they patch fast-changing behavior, or when you tell yourself you'll upstream them later. We started on Rails 3.0, and for years we were behind, and we were falling further behind. We wrote 226 unique monkey patches and peaked at 133 of them live all at once. But once we were on Edge, the upgrades got small and mostly boring, and that gave us the opportunity to pay down tech debt and to start deleting monkey patches instead of adding them. A monkey patch used to mean that Rails fixed this in a version that we can't reach, but now it actually means that we get the chance to contribute to Rails and other gems before the next stable release is out. Thank you.